Hi everyone, my name is Michail Greshishchev. I'm a product owner at Denuvo. For the last just about 2 years, the team and I have been hard at work. I'm working on a next generation solution for catching cheaters in multiplayer games. As part of this adventure, we had an opportunity to reverse engineer a lot of cheats, pretty much to figure out what are the shortcomings of the current generation anti-cheat solutions. And I wanted to share just 3 of the cheats that we found to be actually particularly quite clever. Before I get into the cheats, I just had a few words to say about the organizations that made this talk possible. The first one is Denuvo by Irdeto. They're the #1 video game protection solution. To date, there's just about over 500 million software licenses issued, and the flagship anti-tamper product has the longest crack-free window on the market. Crack-free window is the time between a game is available to the public and available for free to the pirates. And Irdeto, Denuvo's parent company, they're a worldwide security leader. Just over 5 billion devices protected to date, and this includes everything from devices in automotive space to ones in your smart TVs. That said, let's get into the cheats. Whoa.
Move orange paint outside.
That was odd. Not part of the slides. So the first cheat we found particularly clever is achieving radar through virtual private networks. So in cheating, radar is something that gives you an advantage by showing you entities that would not normally be visible to the player. So this could be something like in Fortnite or PUBG, the spawn locations of all the good loot, or maybe in something like Counter-Strike or Rainbow Six Siege, the location of enemy players. And radars themselves are nothing new. Cheaters have been using it for some time, but doing it through VPN actually turns out to be pretty clever, and here's some reasons why. So first, this is what your regular at-home game network probably looks like. The game client could be anything from Xbox, PS4, or it could be a PC or your iPad. It doesn't really matter in this case. Eventually, it hits your home router, and then from there, through a lot of tubes, it reaches the game servers. And this cheat, the implementation is quite simple. You purchase the license, and the cheater says, or the cheat provider says, go on your router, configure it to connect to our VPN service, and then using a secondary device, being a phone, tablet, another computer, or whatever, log into our page, and all of a sudden you see where all the enemies are in your game. So as you can imagine, this is a pretty huge advantage in something like PUBG if you can just see where all the players are on your phone. And the trick here is by adding yourself to the VPN network, now your traffic is routed through their cheat servers. They can use deep packet inspection to extract all of the entities on the map and then render it for you in a Qt application in a web browser. So some of the things that make this particularly clever is there's little to no footprint on the client. I mean, I didn't have to touch my PC, I didn't have to touch my Xbox or PS4, so what is there for anti-cheat to detect in this case? There's some cases where if your game is using certain forms of encryption, they might have to lift a session key from your device. But as you'll see, this is quite trivial to do. It's software as a service. I mean, the whole point, cheat makers out there make cheats to make money. It's a pretty huge business. And in this case, it's quite trivial to turn it into a business. Once your license expires, you can no longer connect to the VPN. So they didn't even have to make DRM for their cheat. It's quite easy to do. And the apps they create for the devices that show you the maps of the players and stuff, they're actually quite good. I mean, these people should get into indie game development and start making mobile games instead of cheats. And then finally, as kind of hinted before, this works on non-jailbroken devices. So if you have a PS4 or something, you're probably still playing against cheaters since this doesn't require modification of the device itself. So the next cheat to cover is Extrasensory Perception, or ESP for short, through direct memory access. So this one is pretty cool. It requires a dedicated PCIe device that you literally plug into your Windows gaming PC. And this thing lets you read directly from RAM, and you can extract cool things like positions of important entities, so enemy units in Fog of War, or players behind walls in a first-person shooter. So the way this works is you have your game client. This could be a Windows or a Linux PC. Mac actually has some pretty cool security against this stuff. So for this sake, it's just Windows or Linux. You buy your FPGA PCIe card. This thing runs you about 150 bucks. Plugs into any of your PCIe slots, could even be 1X. And from there, you have a USB out connection that goes to a secondary device. And this device is actually the one that does all the cheating for you. So it'll read the worldview transformation matrix, so they know how to render the entities on the screen. And then they take your original game's output video and literally overlay all the information on top of it to show where the enemy players are. And again, you can see this is pretty crazy because on the actual PC, the game client, we didn't modify anything. We just stuck in this card and let the built-in Windows driver run the PCIe DMA from it. All of the cheat logic is offloaded to a secondary machine. So some things that make this clever is, again, little to no footprint. I did mention that, yeah, there's a Windows driver involved to get the PCIe card to work, but you can't just ban people for having this card because it's used for legitimate reasons in other cases. So it's a little bit tricky to work with. The ESP overlay works on full screen games. If for some reason we have cheaters in the audience, they would know that cheats frequently require you to either inject the cheat into the game if you're going to run full screen, or they ask you to run the game in window mode just so Windows Aero can overlay all the cheats for you. But in this case, it doesn't matter. It just works on a full screen game. It's safe for streaming. This is actually quite funny because there's hundreds of YouTube and Twitch videos where like cheaters would just accidentally show their overlay during streaming, and everybody would post clips on them like, oh, this popular esports player has been cheating all along. Here's a 3-second clip of him turning off his cheats. In this case, even if you screw up, there's nothing to capture on your main device because the cheat isn't there. And finally, it's high performance, like hardware access to hardware. You can run your 144 hertz monitor and overlay all the cheats on top of it. Even some native cheats struggle to do this just because iterating the entity list in between game frames really tanks the performance. So the final cheat I'll cover, this one is super cool, and that's Aimbot through machine learning. So for anybody familiar with Valve's really cool talk at GDC 2018 on their solution called VacNet, they analyze literally millions of replays of players to find out which are aiming, whose player's aim looks more like a human and whose player's aim looks more like it's assisted by a machine. And what this aims to do is take all these high-quality video streaming services we have, like Twitch TV, YouTube Gaming, etc., take those 60 frames per second, 120 frames per second output videos, and train aiming to make it look perfectly like human. And as you'll see, they actually have a lot of advantages using streams that even Valve struggles to deal with in VacNet themselves. So how does this work? What you see here is a game called Sauerbraten. This is an internal test game that we use at Denuvo quite often. And what the world doesn't know is I'm actually the greatest Sauerbraten player. So I've decided to stream my gameplay in Sauerbraten. So let's say I'm a hacker, and for some reason Sauerbraten has an anti-cheat solution that server-side looks at aim vectors and just bans players that aim way too good. So the first thing I need to do is, from my stream, recover some frame-to-frame data. So for the sake of time, I won't be able to get into exactly how this is done because it's only a 15-minute talk, so you'll have to just believe me for some of it. But the idea is, between each frame, you need to extract the fundamental matrix. This essentially lets you figure out exactly what input did the player provide to the game. So how did he move his mouse in a way that would make the character rotate in a certain way? And then by extracting these sequences of fundamental matrices, you essentially can extract just from one picture the exact mouse movement that the player took. Once you have your mouse movement, again, I refer you to this talk, but you break them up into something that John McDonald called cubes of meat. And then eventually you feed these cubes of meat into your machine learning system or into your deep learning system. And essentially all this deep learning system tries to do is says, given a certain sequence of these inputs, can I predict what the output would be over the next X frames? And what this ends up looking like is, here's your real mouse movement, maybe over 1, 2, 3, 4 frames represented there. And then at this point, I see an enemy player, and I want to press my mouse button to just lock onto them and shoot. So a traditional cheat would kind of snap to the player, or they would use some like really simple smoothing that says, move your cursor slowly, not too fast because the anti-cheat will get you. But the machine learning approach will actually say, hey, on training data set, blah, 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 I've seen that Ninja was in this similar position, and this was the arc he took to get to the target. And instead, the machine learning algorithm would now output this very smooth sequence for you that would get to the target you're looking for. And essentially, if you're John McDonald, Valve trying to use VacNet to find cheaters via server-side cheat detection, you're out of luck because this looks like a human. In fact, this was a human. This was done by a real esports player. So what makes this really clever is it really takes advantage of consistency. At the end of the day, you don't need to be able to aim like a god. You just gotta aim like the best player and do it consistently. Because even someone like Ninja screws up every once in a while when they want to shoot a player. But luckily, if it's automated, it's just very consistent. And as I mentioned before, the advantage is these 60 frames per second Twitch streams and stuff, they actually provide better data than Valve themselves have on their servers. So for example, for CSGO, your replays are recorded at 24 tick rate or 32 tick rate in some cases. So you have higher resolution in this case than they do in their own machine learning services. And finally, there's a lot of talk saying, hey, Google Stadia is around or streaming services around, there's going to be no more cheats. Well, in this case, I don't need a client. I just need to watch someone play, and then all of a sudden I can do perfect inputs on this game, and all I got to do is emulate controller input. So the area of cheating is far from solved just for the sake of having streaming due to techniques like this one. So that said, I know this is a really quick fly-through. I just wanted to make sure we actually fit all the content. Denuvo ourselves, we have our anti-cheat coming out Q2 2020, so look for us on some big-name AAA titles. We're extremely excited for this because we've been testing internally with our early access partners for quite some time. If you want to find out more information on it, there's our website. And if by any chance you want to find my unprofessional contacts, that's my Twitter handle right there, and for any professional questions, you have my email address at the bottom as well. So now would be a good time for questions. Just a reminder to please wait for the microphone.
We have lots of time for questions, so who'd like to start? So you you described these undetectable cheats. How would Denuvo go about detecting those and acting against them?
Yeah, that's a really great question. This presentation was actually an excerpt for a talk we did in GDC 2019, and that included the mitigations that we have in place to deal with them. For the sake of not covering all three of them, I could just maybe cover one of them. So the first example was the VPN-based cheat. So I think most people would go, oh, that's okay, my game has encryption. And what they don't realize is the strength of your encryption doesn't really matter when you have a man-at-the-end attack. It's just as easy to lift a 256-bit key as it is to lift a 512-bit key. You're just copying slightly more bytes. So the idea is to have a strategy for rotating your session key frequently enough where the cheat is forced to live on the client and forced to keep relifting that key. That way you have some surface area you can detect. So that's pretty much our approach for that one. Yeah. But unfortunately, there's no solve-it-all for all of them. They're all very specialized, focused just for those attacks. Yeah. Another cool one to look at, sorry, just to continue on that, the hardware-based cheat, esports players were caught in tournaments using these cheats. So if you're curious, Google around hardware-based cheats, and there's some great articles by ESL, et cetera, that explain how referees are trained to catch this stuff, and what does the hardware actually look like once they confiscate it at a tournament. It's cool stuff to look at.
Just hypothetically on the other cheats, I mean, obviously these do sound really clever, and they do sound like designed to defeat software like Denuvo. Mm-hmm. Hypothetically, then on the other cheats, what methods beyond Denuvo, like if software can't do anything about it, then what methods could exist to defeat these other ones?
So I think at the end of the day, what we came to the conclusion to is the majority of anti-cheat solutions today are kind of focusing on the symptom, not the problem. The analogy we use is when somebody in the Olympics cheats, you don't really look for the method of how they cheated. Like you don't look for, did they take a pill? Did they inject a needle? And anti-cheats right now kind of do this. They go, did they open an invalid handle? Did they map some memory they shouldn't map? They use these kind of very specific heuristics. And similarly for the machine learning approach where they say, did they aim too good or did they aim too fast? This is like taking an Olympic player and being like, did they jump too well, therefore they cheated? Like these detection methods don't make sense. Our approach is more fundamental. We look for what is the root cause of the cheat. So not the method for what that resulted in the cheat, but what is the root cause. And at the end of the day, it pretty much comes down to somebody extracted information from your game that they shouldn't have. Whether it's a network, whether it's something running on your PC, and we need to figure out what are the different vehicles on a Windows platform that you can have for extracting this information. And then we use fundamentals like hardware-based security, virtualization, hypervisors to protect the game to make sure this doesn't happen. Yeah.
So is the future of anti-cheat then from Denuvo's perspective, like is that working with developers, or is it working with Valve, or is it working with hardware manufacturers to help you guys get visibility on players who are extracting information that they shouldn't have, as you put it?
All of the above. It's a full stack. If you want to use hardware-backed security, you need the adoption rate from hardware vendors. If you want to build it into the game engine, you have to work with the game developers, etc. So there's no simple answer to that one, unfortunately. Everybody's involved.
We do have a couple of minutes left. If there's anything else, perhaps you could you tell us maybe a little bit about what state you guys are in when it comes to sort of those partnerships? Are they? Yeah,
sure. We had two large AAA titles which helped us test internally. Of course, for NDA reasons, can't reveal who they are. They contributed, I want to say, just over 600 unique players, which we had an opportunity to test the performance of the anti-cheat, the effect of the anti-cheat, etc. And yeah, the next goal is to just line up with the launch date of a real title and get us out the door. But so far, the experience has been extremely positive.
Very cool, very encouraging. Thank you very much.
Thanks.